If you ask a fish to describe water, it probably can't. It spends its life completely immersed, making the water itself entirely invisible. For centuries, humanity has looked up at the night sky and made that exact same mistake. We see bright stars and distant planets, and we assume the vast space between them is a perfectly empty void. Because we see space as empty, our traditional physics models tell us that gravity must be an invisible pulling force, reaching out across a vacuum to drag objects together. But treating space as a total void is leaving massive gaps in our understanding of the cosmos. Our assumption of emptiness might be the exact reason our mathematical models keep coming up short. To fix the math, we have to flip the script. Imagine space isn't an empty room, but a continuous, highly pressurized fluid. In this liquid universe framework, gravity operates completely differently. Instead of the Earth pulling you down on the inside, the dense, pressurized fluid of space is actually pushing you down from the outside. This means the matter we see, from our own human bodies to massive galaxies, aren't solid balls floating in nothingness. They are actually localized bubbles or spinning whirlpools moving through a massive cosmic fluid. When we look at this document on unified field principles, the math confirms this approach. By treating the universe as a pressurized ocean, we can start using equations meant for fluid dynamics to track how energy and matter actually move without getting lost. The problem with our standard physics is that it tries to map the universe using a rigid 6-point grid, mostly just tracking where an object is and how fast it's going. But you can't throw a static grid over a flowing ocean. That rigid math completely misses the internal tension, the drag, and the natural flow of the medium itself. To map the flow, we look to the unified liquid push equation, a system of 24 variables calculating deep space fluids. Unlike static numbers, these shift with environmental pressure, seen here in the reciprocal flow term, accounting for the universe's simultaneous push and pull. To truly understand how the cosmos operates, science has to let go of frozen equations and adopt a mathematical framework that breathes right along with the system it's measuring. Think about dragging your hand slowly through a swimming pool. When you move gently, the water glides around your fingers with almost zero resistance. Now imagine swinging your arm through that same water as fast as you can. You create a massive chaotic wake, and the water fights back, making it incredibly hard to move forward. The variables in our cosmic fluid act exactly the same way. As an object speeds up, the viscous drag of the surrounding space increases, forcing the other variables to adjust and find a new balance. In a liquid universe, there are no isolated actions. Every single movement creates an equal, immediate fluid reaction to keep the cosmic ocean perfectly balanced. This brings us to what we call the straight tape error. For decades, scientists have been trying to measure a curved, swirling fluid universe using straight, rigid, three-dimensional rulers. When you try to measure a complex, flowing spiral with a straight edge, you miss the curves. Over cosmic distances, those tiny missed measurements add up to massive mathematical errors and huge amounts of supposedly missing data. The liquid universe framework corrects this by expanding our perspective. Instead of flat 3D math, the framework reveals that the universe operates in 9.6 active dimensions. That fraction provides the exact physical space where the fluid's natural curve hides. Moving away from a neat whole number like 10 and dropping down to a fractional 9.6 finally patches the mathematical gap that has plagued standard physics for a century. But the most important breakthrough of this entire model is that 9.6 isn't a frozen number either. It is a dynamic, breathing state. This datasheet shows how this works through dynamic variance. Calculations reveal dimensions fluctuate based on the cosmic fluid's pressure. Notice this 0.03% variance at the bottom. This tiny fluctuation is exactly what scientists mistake for dark matter. There is no invisible ghost matter holding our galaxies together. There is only the natural, fluctuating fluid pressure of the cosmic ocean pushing inward. The next time you look up at the night sky, don't picture a cold, empty vacuum. You are looking at a living, breathing ocean, and we are all swimming right through